Jai Jagannath. Welcome to More Physics. In the lecture number 2, that is in the last class, we had discussed the Coulomb's law. Coulomb's law and some numericals based upon the Coulomb's law formula. So today we will start the same chapter number 21 and we will start electric field and electric force. Electric field and electric force. So now question comes, what is electric field? Before going to discuss the electrical field or electric field, let us take an example of political field. Political field. Just compare the political field with the electrical field. So what is political field? Suppose this is a politician. Say this is your Navin Patnaik, Chief Minister of Odisha. Its influence can be realized within Odisha. That means if anybody comes within Odisha, then Navin Patnaik can attract this fellow if he belongs to the same party, or repel to this person if he belongs to opposite party. That means the influence of this politician can be realized within this Odisha. So this Odisha is called the political field of this politician, that is Navin Patnaik. Similarly, what is electric field? Just compare electric field. So electric comes from the word electron. Electron is a charge. Electron is a charged particle. So let us take, this is a charged particle Q. This is the main charged particle. You can say this is source particle. Source charged particle. So now what I will do, I will bring another charge, let us say Q naught. This Q naught is called test charge. This Q naught is called test charge, whose magnitude is very small and it has no electric field of its own. Its magnitude is very small, that it tends to 0, so that it has no electric field of its own. So now we will say, so if this Q source charge will exert a force on Q naught, then we can say this Q naught is lying within the electric field of this Q charge. Let us say I will bring this test charge here, and this source charge is also exerting a force on this Q naught. So we can say this Q naught is lying within the electric field of this charge. But if I will bring this test charge here, and there is no force between this source charge and test charge, so we cannot say this Q naught is lying within the electric field of this. That means this Q naught is lying beyond the electric field of this charge. So what is electric field? Electric field is the area. Suppose, so I am taking the electric field, this area. So this is the electric field of this source charge, where if any charge particle is brought inside this field, so those charge particle will experience the force due to main charge or due to source charge. So this is called electric field. This area is called electric field. Of which particle? Of charge particle Q. I think it is clear. So what is the definition of electric field? So we can write electric field is the area within which the influence of a charged particle can be realized. So this is your electric field. Now we will find what do you mean by electric field intensity, electric field intensity, or simply it is called electric field strength, or simply we can write electric field. So now see, suppose this is my source charge Q. I want to find the electric field intensity at any point A within the electric field of this source charge. So this is your electric field of the source charge. I want to find electric field intensity at A. And this A point is at R distance from the source charge. So now to find the electric field intensity at any point, I have to take a unit test charge, unit positive test charge. Okay, I have to take a unit positive test charge, that is Q naught. So positive test charge is Q naught. So now you first find out what is the force on this Q naught charge due to main charge Q. So according to Coulomb's law, the force by this source charge on Q naught charge is equal to K into Q1 Q2, that is Q naught divided by R square. So what is K? Where K is the constant, which is equal to, I have taken 9 into 10 to the power 9 divided by epsilon r. Epsilon r is the relative permittivity of this medium. So this is the force on Q naught charge. So F is force on Q naught charge. Q naught is the positive test charge. So if I will find force on unit positive test charge, unit positive test charge, so that is equal to force on unit positive test charge is equal to F upon Q naught. So for Q naught force, for Q naught charge, force is F. For unit positive test charge, force is equal to F by Q naught. So this F by Q naught is called electric field intensity. So this is the electric field intensity, which is defined as force experienced by a unit positive test charge. For Q naught charge, if force is F, for unit charge it is F by Q naught, that is called electric field intensity. Of course, the Q naught is test charge whose value is very small. I have taken initially I have told. So here we can write limit Q naught tends to 0. That is Q naught is very small. So it is not 0. If it is 0, something by 0 is infinite. So it is very less. That is Q naught tends to 0. So this is the numerical formula of electric field intensity, that is E is equal to limit Q naught tends to 0 F by Q naught. So this is in which form? This is in scalar form. This is in scalar form. But electric field intensity is a vector quantity. Electric field intensity is a vector quantity. So if I will write in vector quantity, so I can write E is equal to limit Q naught tends to 0 F vector divided by Q naught. So this is in which form? Vector form. This is in vector form. You see, I have taken F is equal to Q naught by R square. This is force for Q naught charge. Then what is force for unit charge? That is F by Q naught. So I can say electric field intensity at any point is equal to F by Q naught. And what is F? Q naught by R square divided by Q naught. Q naught cancel. So that is Q by R square. So this is the expression of electric field intensity in numerical form. So here K value is equal to 9 into 10 to the power 9 by epsilon r. So we can say E is equal to 9 into 10 to the power 9 divided by epsilon r Q by R square. This is the magnitude of the electric field intensity at any point due to a source charge. So this is electric field intensity. This is electric field intensity at any point due to a source charge. due to a source charge, that is Q. So now what you will do when you will calculate, when you will solve some numerical? So what you will do, suppose I want to find, suppose there is a charge Q, I want to find electric field intensity at A point, which is r distance from the main charge. So what you will do, first I had taken Q naught. On Q naught I had calculated a force. On unit charge I have calculated the force, that is this value. So what I will do, I will take initially a unit positive test charge at A point. Now calculate the force on this unit positive test charge by this source charge. According to Coulomb's law, the force for unit charge, which is equal to electric field intensity, is equal to K Q1 Q2, that is Q source charge, and unit positive test charge is 1 divided by r square. So that is equal to K Q by r square is the electric field intensity at any point due to a source charge Q. So now this is your electric field intensity in which form? Scalar form. So if I will write in vector form, what will you write? So E vector is equal to K Q by r square into a unit vector, that is r cap. So what is r cap? R cap is unit vector along the direction of force on unit positive test charge. Now see, suppose this is this is a positive charge. Let us say this is a positive charge. To define electric field intensity, we have to keep always unit positive test charge. So now this plus Q will repel this plus 1 charge along which direction? Along this direction. So this is the direction of r cap, which is also this is the direction of electric field vector, that is you can write E cap. So electric field direction is always away from a positive charge. So suppose I will keep here plus 1. If I will keep a unit positive test charge freely, then this positive test charge will move, this positive test charge will move along this line. So this is the direction of the electric field intensity. So always electric field intensity is away from a positive charge body. But if I will take a negative charge, so I want to find the electric field intensity at A point. So what I will do? I will keep plus charge, unit positive test charge. Now this minus Q will attract this plus 1 towards it. So this is the direction of electric field intensity at which point? A point. So in general, we can write electric field is away. This is, you see, electric field is away from a positively charged body, and electric field is towards to a negatively charged body. So this is about the formula used for electric field intensity. Now we'll find, suppose you take a two oppositely charged body. Let us say this is a positively charged body plate and this is a negatively charged plate. So I want to find, and this is infinite plate. That means there is no meaning of infinite. So it is a large plate. I want to find electric field intensity at this point A. So what I will do? I will keep a plus 1 charge here. Now here we see the lower plate is positive. So this positive will repel this plus 1 along this direction. And this is negative charge. This will attract this plus 1 along this direction. So that means the electric field intensity direction inside a charged plate is always from positive plate to negative plate. So this is the direction of electric field intensity. Everywhere the electric field intensity direction is from positive to negative plate. So now, what will happen if I will bring suppose I will bring a unit, suppose I will bring a plus Q charge here. So what will happen? So what is the formula of electric field intensity? Electric field intensity is nothing but force per unit charge. So that implied F is equal to Q into E. So the vector of F depends upon the vector of E. So if Q is positive, so what is the direction of this force? What is the direction of the force experienced by this positive charge? So we can say the direction of force is same as direction of electric field if charge is positive. So if charge is positive, direction of force is same as direction of E vector. Now this Q charge will experience a force along the direction of electric field. What is the magnitude of this force? Magnitude of this force is equal to F is equal to QE. Now I will bring a negative charge minus Q. So inside an electric field, if any charge particle is brought, so that charge particle will experience a force. So what is the formula of force? F is equal to charge into E. So here charge is minus Q. Here charge is minus Q. So F is equal to minus QE. So if I write the vector, so that is minus Q into E vector. This can be written as Q into minus E vector. So what is the magnitude of this force? Magnitude of this force is nothing but magnitude of this. So magnitude of anything is positive, that is QE. But what is the direction of the force? So direction of force is, you see, direction of force is equal to Q into minus E. That means this minus Q charge will experience a force opposite to that of electric field. You see, the direction of force is negative of direction of electric field. So here electric field is upward. The minus Q charge will experience a force in downward direction. But what is the magnitude of that force? F is equal to QE. So always remember, if Q is positive, direction of force is same as the direction of E. And if Q is negative, then direction of force is opposite to that of electric field vector. Then we will say, what is lines of force? What is lines of force? Now suppose I will bring a positive charge here, plus Q. I want to find the lines of force due to this positive charge. What I will do? Bring a unit positive test charge here. So now this positive Q charge will repel this plus 1 Q charge along this direction. So this is the line on which if a unit positive charge is kept, that will move freely. So this is your lines of force at this point due to this charge. So within the electric field, if I will bring a unit positive test charge and I will keep this positive charge freely, then this charge particle will exert a force on this positive charge, and this positive charge will move freely along this line, and that line is called lines of force. From the name it indicates, lines of force is the line. From this sentence you can write, lines of force is the line on which electric force or electrostatic force acts. So this is called lines of force. So lines of force, or you can say lines of force is the line along which a unit positive test charge moves freely inside an electric field. So this is the lines of force. Then what do you mean by uniform electric field? Uniform electric field. So from the name it indicates the uniform is same. Electric field means electric field strength. Suppose this is a space where electric field strength everywhere is same. So how can you represent? So electric field can be represented by a line. So if all the lines magnitude are same and direction are same and they are equally spaced, then it is called uniform electric field. For uniform electric field, lines of force, magnitude, all are same, direction are same, and they are equally spaced. So this is called uniform electric field. That means the magnitude of electric field strength remains same, direction of electric field everywhere remains same. That is called uniform electric field. Now, if I will take this is a lines of force, this is a lines of force, this is a lines of force, this is a lines of force. So this is non-uniform electric field. Non-uniform electric field. Because here magnitude of the lines of force are different. Suppose I will take this is an electric field. So though the magnitude of each lines of force are same, but their direction are different, this is also called non-uniform electric field. So now see, suppose I will bring a positive charge. Now what is the formula of electric field intensity due to a point charge? Kq by r square. So here electric field intensity is inversely proportional to r square. If distance increases, electric field strength decreases. So now if I will take this point and this point. So here this point A and this point B. So A point is nearer to the source charge, so electric field strength is more. But here this B charge is more away from this positive charge, so here electric field intensity is less. So this is the representation of electric field intensity. I think it is clear. Suppose this is a negative charge. I want to show the electric field vector or lines of force. So here nearer to the charge the electric field is more, away from the charge electric field is less. So in this way we can represent the electric field, and this is a negative charge, so lines of force or electric field is always towards the negative charge. But this is a positive charge, lines of force is away from the positive charge. If distance is less, electric field strength is more, that is shown by a bigger length, and this point is away from the charge, so electric field is less, and the vector is shown by a small line. Next, suppose you take a conductor. This is a conductor, and we will take electrostatic condition. Electrostatic condition means charge are at rest. So if charge are at rest, then the force on the charge must be zero. So that indicates the electric field intensity inside the conductor is zero. Always remember, during electrostatic condition, electric field intensity inside the conductor is zero. If not zero, what will happen? If electric field intensity inside the conductor is not zero, what will happen? The charge particle will experience a force, that is F is equal to QE. So if charge particle will experience a force, then charge will be in motion. Charge will move. And we know if charge will move, current will establish. Current will be established. So in the electrostatic condition, the electric field intensity inside the conductor is always zero. Now we will discuss test your understanding 21.4 of University Physics book. So here question is, a negative point charge moves along a straight line towards a positively point charge at rest. Suppose this is a positively positive charge, let us say plus q. Now, according to the question, a negative charge is moving along the straight line towards a positively point charge at rest. Definitely this positive charge will attract this negative charge. What remains constant for force on negative charge? That is magnitude, direction, both magnitude and direction, neither, both. You see, when this minus q charge is moving towards this positive charge, what will happen? So as time increases, the distance of separation between this q and this minus q decreases. If so, then magnitude of force, which is inversely proportional to r square, so this will increase. So what is the conclusion? The magnitude of this force will increase. The magnitude of force will increase, or you can say the magnitude of the force will change. So question is, what remains constant for force on negative charge? So here force value will change. But you see, the direction is always towards the positive charge. So direction will always remain constant. So direction remains constant, but magnitude of force will change. So which answer is correct? Constant for negative charge. So direction must be remain same. So answer is second bit. Now come to second part of this problem. If a negative charge moves around a positive charge on a circular path, suppose I will take this is a positive charge, and this negative charge is moving along the circular path. So what will remain constant? Now you see. So this is minus q. This is positive charge lying at the center. The distance is your radius. If this minus q charge will move to this point, so here also radius, distance will remain constant. So everywhere on the circular path, the distance, that is radius, the distance between charge and plus q and minus q remains constant. So if distance remains constant, F is equal to k q by r square. Here k is constant, q is constant, r is constant. So magnitude of the force always remain constant. But what will change? So if this is the position of minus q, this minus q will be attracted by plus q along this direction. So at this point minus q will be attracted by this q charge along this direction. So here minus q will be attracted by this q charge along this direction. That means direction will change. Direction everywhere it will change. So this is the answer. So answer is but our question was what remains constant. So here in this case force remain constant. That is magnitude of the force remain constant. So which answer is correct here? First bit. Now see, we will solve an example problem 21.6 of University Physics book. So here a point charge q of minus 8 nanocoulomb is located at the origin. Let us say this is the x-axis, this is the y-axis, this is the origin. So here charge of minus 8 nanocoulomb is present at the origin. So we have to find electric field intensity at the point x is equal to 1.2, y is equal to minus 1.6. That means the x coordinate is, so here let us say this point is your A. So what is the coordinate of A? X is equal to 1.2 meter and y is equal to minus 1.6 meter. So this is the negative y-axis, this is the positive x-axis. So I have to find the electric field intensity at A point due to this source charge of minus 8 nanocoulomb. So before going to discuss this problem, you know displacement vector. Displacement vector. So what is displacement vector? Suppose this is a point A, this is a point B. A particle is moving from A to B. So this is your displacement vector. Particle is moving from A to B. So I will find the displacement vector. This is the origin. and this O, this is, let us say this is O. So OA vector is the position vector of A, and OB vector is the position vector of B. And let us say the coordinate of A is x1, y1, coordinate of B is x2, y2. Particle is moving from A to B. I want to find the displacement vector joining from A point to B point, which is R vector. So using the triangle of vector addition we have read in the vector chapter. So I can write OA vector plus AB vector is equal to third side of the triangle, that is OB vector. Or you can say AB vector is equal to OB vector minus OA vector. So this OB vector is the final position vector, OA vector is the initial position vector, and this is your displacement vector. And we also know from the vector algebra, so what is the position of vector of B? What is the coordinate of X? S2 I cap plus Y2 J cap is the position vector of B. And what is the position vector of A? X1 I cap y1 j cap is the position vector of A. So that implied it is x2 minus x1 I cap plus y2 minus y1 j cap. So this is the displacement vector from A point to B point. That is final x minus initial x coordinate I cap plus final y minus initial y j cap. So now basing upon this theory we will solve in this problem. Now see, this is which charge? Negative charge. So I want to find electric field intensity at A point. What I will do? I will mentally keep a unit positive test charge here. And this positive charge will be attracted by this negative charge. So this is the direction of electric field intensity at A point. We know electric field intensity is always towards a negative point charge. Okay. So now I want to find, so let us say this is O point. So what is the magnitude of the electric field intensity? First you see, let us say this is B. So what is the OB distance? OB distance is equal to 1.2. And what is AB distance? AB distance is equal to 1.6. Then you find out what is OA distance. So what is OA distance? It is square root of OB square, 1.2 square plus AB square, that is 1.6 square. So I think it will come 2 meter. So now you first find out what is the magnitude of electric field intensity at A point. What is the formula? K Q by R square. And if medium is not specified, then you have to take epsilon r is equal to 1. So that is 9 into 10 to the power 9. And what is the magnitude of this charge? So I am not giving the symbol or vector symbol. So whatever may be the charge there, either positive or negative, you always take positive charge. That is magnitude of the charge. What is the magnitude of charge? 8 nanocoulomb. Nano means 10 to the power minus 9 divided by r square. R is nothing but the distance between O and A. So what is the distance between O and A? It is 2. So 2 square. So if we will calculate, I think it will come 18. And what is the unit of electric field intensity? Newton per coulomb. So electric field intensity is force per charge. Force is Newton, charge is coulomb. So this is the electric field intensity at A point. But what is the direction? Direction is along A to O. So if I will write the electric field intensity at A point in vector form, I have to write its magnitude and the direction. So direction is along which line? A to O line. So I will write AO, unit vector of AO, because direction of electric field intensity is along A to O line. So I will take a unit vector along A to O line. So A to O line vector, the unit vector of AO vector is equal to the direction, we will give the direction of EA vector. So to find the AO, the unit vector of AO vector, first I have to find what is OA vector. So A is the OA vector is nothing but the position vector of A. So any position vector can be written as its x coordinate I cap, its y coordinate j cap. So this is your OA vector. but I want to find AO vector. So AO vector is negative of OA vector, which is equal to minus 1.2 I cap plus 1.6 j cap. So what is the magnitude of AO vector? What is the magnitude of AO vector? It is x component square, y component square, square root. So which is nothing but 2. So now I want to find AO cap. So AO cap is the unit vector of AO vector, that is AO vector divided by the magnitude of AO vector. What is AO vector? Minus 1.2 I cap plus 1.6 j cap divided by its magnitude 2. So which is equal to, if you calculate, it will come minus 0.6 I cap plus 1.6 by 2, that is 0.8 j cap. So this is the unit vector of AO cap, and this unit vector of AO cap is nothing but the unit vector of EA. So I can write the EA vector is equal to EA magnitude. What is the EA magnitude? What is the magnitude of electric field intensity at A? We have already derived, that is 18, into the unit vector of AO vector. Unit vector of AO vector is minus 0.6 I cap plus 0.8 j cap. So if we split this, if we multiply this, you will get minus 10.8 I cap plus 14.4 j cap. So this is the electric field intensity at A point due to this source charge O. So I think it is clear to everybody. So now see. So we will discuss example 21.9. We have to find field of a ring of charged particle. Suppose I will take a ring. Clear? So this ring, the total charge of the ring is Q. And this total charge Q is divided uniformly on the ring. And the radius of the ring is, say, A. I want to find electric field intensity at P point. This P point is lying on the axis of this ring. This is the origin. So this P point is the axial point. And this distance between O to P is, say, x. So I want to find electric field intensity at P point. So what I will do? The total charge Q is uniformly distributed over this ring. So we have to find what is the linear charge density. Linear charge density. What do you mean by linear charge density? It is the charge distributed per unit length. So what is the total length? Total length is the circumference. Circumference is nothing but 2 pi into radius, 2 pi a. So for 2 pi a distance, the total charge distributed is Q. For unit distance, the total charge distributed is Q by 2 pi a. So this is your linear charge density. So what I will do, I will take a very small element on this ring. And this small element, let's say the distance is ds. I want to find the electric field intensity at P point due to this small element having length ds. Why? Because we have derived the electric field for point charge. So here I will take a very small element whose length is ds, and the charge on this ds element is, say, dq, and for this dq it is treated as a point charge, and find out the electric field intensity at a P point, due to this dq charge. Since the charge is very small, so electric field intensity is also very small, that is taken to be dE. So electric field intensity at P point due to the small charge of length ds and charge dq is equal to dEp is nothing but k charge divided by distance square. So what is the distance? You see, this is the radius a, this is the x. So actually this ring is lying in the plane vertical, that is perpendicular to this board, and this distance is the hypotenuse, that is called a square. This is a, this is s. So a square plus x square square root. So we know electric field intensity is equal to k q by r square. So this r square means it is a square plus x square. So this is the electric field intensity. Okay. So but what is k? K is equal to 1 upon 4 pi epsilon naught epsilon r. So if I will take, this is air medium, epsilon r is equal to 1. So that is dq by a square plus x square. So this is the electric field intensity. This is the electric field intensity at P point due to ds element. Similarly, what you will do, you just take a small element of length ds just opposite to this element. That is, this element was at top. Now take a same similar small element just at the bottom, and you find, acha, so what is the direction of electric field intensity at P point due to this dq charge? So this dq is positive, and to find electric field intensity we have to keep plus 1 charge. So this positive charge will repel this plus 1 along this direction. So this is the direction of electric field intensity due to, at P point due to plus q charge. Similarly, if I will take a similar element just opposite to this and find the electric field intensity at P point, again the electric field intensity will remain same because charge is same, distance is also same. So but what is the direction? This plus q will repel this plus 1 along this direction, along this direction. So this is also electric field intensity at P due to just bottom point. Okay. So if the top point I will take a positive, at the bottom point I am just writing negative. That indicates. So now see, let us say this angle is alpha. If this angle is alpha, this angle is also alpha, opposite, vertical opposite. And if you see this angle same, so that means this alpha, this is also alpha. So now what we will do, we have to find what you see at this P point. If we will add these two vectors, what will happen? The y component of this vector will lie along this, and y component of this vector will lying above this. So this value will remain same and they are opposite. So y component of these two vector will cancel. Only which component will exist? X component. So what is the x component of this vector? D, E, P cos alpha. Here also the s component of d vector will lie along this direction. So that is d cos alpha. But this is the electric field intensity at P point due to a small charge. But I want to find total electric field intensity at P point. At P point due to whole ring. Due to whole ring. So what will do? So I have to find the electric field intensity due to whole ring, which is nothing but integration of which component? X component, because y component are cancelled. So what is the x component? dep cos alpha. So that is dep cos alpha. Okay. So that is equal to, what is d? So what is dep? We have already calculated. So that implied electric field intensity at P point is equal to dep is equal to what? dq by 4 pi epsilon naught a square plus x square into cos alpha. You see, this is alpha. So what is cos alpha? In this right angle triangle, cos alpha is equal to base by hypotenuse. Base is x, hypotenuse is a square plus x square square root. So that is equal to dq. That is dq. What is dq? What is dq? dq is charge on this small element whose length is ds. Okay. So you know what is lambda? Lambda is charge per unit length. Lambda is charge per unit length. But what is the length of this dq? That is ds. So for unit length, The charge is lambda. For ds length, what is the charge? The charge is equal to lambda into ds. So in place of dq, what I will put? Lambda into ds. So that implied electric field intensity due to whole ring is equal to dq. dq is equal to lambda ds into x divided by 4 pi epsilon naught. This is your a square plus x square 3 by 2. And you have to take the integration. In this integration, you see which are constant. Lambda is constant, x is constant, because x is the distance from the center of the ring to this axial point P, that is fixed. So x is constant, lambda is constant, 4 pi epsilon naught constant. A, what is A? A is the radius of the ring. Everything is constant. Only variable is ds. So you have to integrate ds. ds means length. So how the whole ring will be covered? So if I will take the lower limit of the length is 0, and total length, full length is equal to circumference. What is the circumference? 2 pi a. So just integrate this. So bring all the constant outside, that is lambda x by 4 pi epsilon naught s square plus x square 3 by 2 integration of ds, that is 0 to 2 pi. So that is equal to lambda x by 4 pi epsilon naught s square plus x square 3 by 2. What is the integration of ds? That is s, length, that is s. So first you have to put upper limit, then lower limit. So put s is equal to 2 pi a minus 0. So that implied it is lambda into 2 pi a into x divided by 4 pi epsilon naught s square plus x square 3 by 2. So here you see lambda into 2 pi a. So what do you mean by this? Lambda is equal to what? Q by 2 pi a. Then what is Q? Q is equal to lambda into 2 pi a. So in place of lambda into 2 pi a, I will put it is Q, total charge Q. So Q by 4 pi epsilon naught s square plus x square 3 by 2 into x. This is the electric field intensity at which point? Axial point, due to a uniformly charged distributed ring of magnitude q. Okay. So now its application. If this P point will lie at the center, so what will happen? X value will be 0. So at center, that is P lies at the O point. So here x is equal to 0. So if we put x is equal to 0, then electric field intensity at the center of the ring will be 0. And if this P point will lie far away from the ring, that is point lies far away from center, that means x is very large. X is very large comparing to the radius a. So if x is very large comparing to a, so what will happen? X square is also very greater than a square. So in this denominator part, we can neglect a square comparing to x square. So if we neglect a square, then what will be the electric field intensity at far away point? You can say infinite distance. So what will write? So electric field intensity at far point is equal to neglect a square compared to x square. So if we neglect a square, that is 0. So x square 3 by 2, 2 cancel, x q. So here x, here x q. So 1x will be cancelled. So electric field intensity will be q by 4 pi epsilon naught x square. So which behaves just like a point charge. So when the point P lies far away from the charged ring, so in that case the whole ring will behave as a point charge. So for what is, what is the electric field intensity due to a point charge? Q by 4 pi epsilon naught x square. So this is the electric field intensity. So I think we have discussed here the electric field. What do you mean by electric field? What is electric field intensity? And we have solved some numericals on this. So I think you enjoyed this video. So please subscribe this channel so that new video notification you will get. And if you are liking actually, then share to your friends. So next class we will continue the last class of this chapter 21.9. So in the last class, in the coming class, we will discuss the electric dipole. So with this, I am concluding my class. Okay, bye.